Almonds are one of the most widely consumed nuts on Earth, found in everything from snack packs and baked goods to plant-based milks and protein bars. Yet few people realize the sheer industrial scale required to harvest, shell, sort, and process almonds by the millions every single day. What looks like a simple nut is actually the final product of precision agriculture, seasonal timing, mechanical force, optical inspection, food safety engineering, and global logistics working together in near-perfect coordination. Almond production is not just farming. It is a tightly synchronized system that transforms fragile tree fruit into shelf-stable ingredients shipped around the world. And today on the How Factory, we're going deep into almond orchards and processing facilities to see exactly how almonds are harvested, shelled, and processed by the millions. Almonds have been cultivated for thousands of years, with origins tracing back to the Middle East and Central Asia. Ancient traders carried almonds along early trade routes because they were nutritious, lightweight, and naturally long-lasting. Over time, almonds spread into Mediterranean agriculture and eventually into California, which today produces the majority of the world's almonds. Modern almond farming, however, bears little resemblance to ancient hand harvesting. Today's orchards are engineered for machines, efficiency, and uniformity. The process begins years before a single almond is harvested. Almond trees take several years to reach full production, and orchards are carefully planned with consistent tree spacing, irrigation systems, and soil management. During spring, almond trees bloom, relying heavily on pollination, often assisted by millions of managed honeybees brought into orchards for a short but critical window. Once pollinated, almonds begin developing inside a green outer hull that protects the hard shell and kernel within. Throughout the growing season, farmers manage water, nutrients, and pest control with extreme precision. Almonds are sensitive to stress, and uneven growth affects shell hardness, kernel size, and processing efficiency later. As summer progresses, the green hull begins to dry and split open naturally, a signal that harvest time is approaching. Harvest timing is critical. Almonds must be harvested when moisture levels are low enough to prevent mold, but not so dry that kernels become brittle. Modern almond harvesting is fully mechanized. Large machines called tree shakers drive through orchards and clamp onto tree trunks. In seconds, powerful vibrations shake the tree, causing almonds to fall cleanly onto the orchard floor. The process looks violent, but it is carefully calibrated to avoid damaging the tree. Once almonds are on the ground, they are left to dry for several days. Sun and airflow reduce moisture content further, preparing the almonds for pickup. Weather conditions are monitored closely. Rain at this stage can ruin an entire crop. When conditions are right, sweepers move through the orchard, raking almonds into neat rows. Pickup machines then lift the almonds from the ground using vacuum and conveyor systems, separating them from dirt, leaves, and debris. The harvested almonds are transported to hulling and shelling facilities, often within hours. At arrival, almonds are weighed, logged, and sampled for moisture and quality. From this point forward, the process becomes increasingly industrial. The first major step is hulling, removing the dried outer hull. Almonds pass through hullers where mechanical rollers and friction systems crack and strip away the leathery outer layer. Hulls are separated using airflow and screens. Nothing goes to waste. Almond hulls are commonly reused as livestock feed or soil amendments. Once hulled, almonds still have a hard shell protecting the edible kernel. Shelling is one of the most critical steps. Almond shells vary naturally in thickness and hardness, so shelling machines must crack shells without crushing the kernel inside. Almonds pass through calibrated cracking rollers that apply just enough pressure to split the shell. This process requires constant adjustment because over-cracking leads to broken kernels, while under-cracking leaves shells intact. After cracking, a mixture of shells, kernels, and partially shelled almonds moves through a complex separation system. Air classifiers blow lighter shells away while heavier kernels fall downward. Vibrating screens and gravity tables further separate material based on size and density. This entire stage operates continuously, handling tons of almonds per hour. At this point, almonds look clean, but quality control is just beginning. Kernels pass through optical sorting systems equipped with high-speed cameras, lasers, and sometimes X-ray sensors. These systems inspect each almond individually in milliseconds, identifying defects such as discoloration, insect damage, mold, shell fragments, or foreign material. Defective almonds are ejected instantly using air jets. This optical sorting is essential for food safety and consistency. Once sorted, almonds may undergo pasteurization, a mandatory food safety step in many regions. Pasteurization eliminates harmful bacteria without cooking the almond. Methods include steam treatment or controlled dry heat. Temperature and exposure time are tightly controlled to preserve texture, flavor, and nutritional value. After pasteurization, almonds are cooled and stabilized. From here, processing diverges depending on the final product. Whole raw almonds may proceed directly to packaging. Others move into further processing lines. For roasted almonds, kernels enter large rotating ovens or continuous roasters where hot air evenly roasts them at controlled temperatures. Roasting enhances flavor and reduces moisture further. Sensors monitor color and aroma development to prevent scorching. Some almonds are sliced, diced, or slivered. Precision cutting machines align kernels and slice them cleanly without shattering. Uniform thickness is critical for baking and confectionery applications. Almonds destined for flour or meal are ground in stages, often under cooled conditions to prevent oil release that could cause clumping. For almond butter or almond paste, kernels are ground into a thick, oily mass using industrial mills. Grinding releases natural oils, forming smooth or textured spreads depending on specification. Temperature control is essential. Excessive heat degrades flavor and causes oil separation. Almonds used for almond milk undergo yet another process. They are blanched briefly to remove skins, then ground and mixed with water. The slurry is filtered, separating almond solids from liquid. The liquid becomes almond milk, while solids are repurposed for flour or animal feed. Every fraction of the almond is utilized. Throughout processing, almonds are constantly sampled and tested. Quality control teams measure moisture content, fat stability, microbial safety, and visual appearance. Almonds are particularly sensitive to moisture. Too much leads to mold, too little affects texture. Facilities operate under strict hygiene standards with controlled airflow, sanitation schedules, and traceability systems. Packaging is the final high-speed stage. Almonds are weighed automatically and packed into bags, cartons, or bulk containers depending on destination. Packaging materials are designed to protect against oxygen, light, and moisture. Some packages are flushed with inert gas to extend shelf life. Labels include origin, batch numbers, and processing details to support global traceability. Robotic palletizers stack packaged almonds for shipment. Finished pallets move into climate-controlled warehouses where temperature and humidity are maintained to preserve quality. Almonds may be stored for extended periods before shipment, allowing year-round availability despite a single harvest season. Distribution is global. Almonds are shipped by truck, rail, and ship to food manufacturers, retailers, and export markets worldwide. Logistics systems track inventory rotation carefully, ensuring older stock is shipped first. Because almonds are a major export commodity, they must meet international quality and safety standards at every step. Sustainability plays a major role in modern almond processing. Almond shells are used as biofuel or livestock bedding. Hulls become feed. Water used in processing is filtered and reused where possible. Farms increasingly adopt efficient irrigation technologies to reduce water use. While almond farming is resource-intensive, efficiency improvements continue to reshape the industry. What makes almond processing remarkable is how a delicate agricultural product is transformed into a stable global ingredient without losing its natural value. Almonds must be shaken violently from trees, cracked open mechanically, blasted with air scanned by lasers, and shipped across oceans, yet still arrive intact, safe, and nutritious. From ancient hand-harvested orchards to modern tree shakers, from cracking rollers to optical sorters operating at impossible speeds, the almond's journey reflects the evolution of agriculture into industrial precision. Every almond represents years of growth and seconds of processing. And that is exactly how almonds are harvested: dried, hulled, shelled, sorted, processed, packed, and shipped, transforming tree-grown fruit into one of the world's most valuable and versatile food ingredients. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the farms, factories, and systems behind everyday products.